Good morning, class. Today let's study about the third study of compounds, that is nitric acid, and that we will be discussing about the preparation of nitric acid, laboratory preparation, manufacture, chemical reactions and all. Okay. Now, nitric acid, the molecular formula is HNO3, which have the molecular mass as 63 when you calculate it by putting the atomic masses and all. And the structure of nitric acid can be written in this way. A nitrogen shows valency of 5 in this case. Now, laboratory preparation of nitric acid. How we can prepare nitric acid in lab? The reactants used are concentrated sulfuric acid with potassium nitrate, or we can take sodium nitrate. Okay. Now, the procedure is a mixture of equal parts by weight of potassium or sodium nitrate and concentrated sulfuric acid is heated gently to 180 degrees Celsius to 200 degrees Celsius in a glass retort. Sulfuric acid is a non-volatile acid and produces volatile nitric acid on reacting with potassium nitrate or sodium nitrate. So you need to take a glass retort. In this, we'll take a mixture of concentrated sulfuric acid and sodium or potassium nitrate. So what, and it is connected to another round button flask, we can say. Now what will happen, as we heat this compound, the reaction between these two takes place. Okay, so when potassium nitrate is treated with sulfuric acid, it is going to form potassium bisulfate and nitric acid is formed. Okay, if the temperature is less than 200 degrees Celsius. Similarly, when sodium nitrate is treated with sulfuric acid, it will form sodium bisulfate and nitric acid. Now this nitric acid that is produced will, with the brown fumes, will pass through this tube and it will be collected over here, and it is cooled under a tap. Okay, it is cooled under a tap. Now the collection, how we can collect the nitric acid gas. The vapors of nitric acid are condensed to a light yellow liquid by chilling the receiver with running cold water. So the receiver, that is this one, are the nitric acid are collected by cooling it with the running water. So the first nitric acid that is formed will be yellow in color, so that yellow color can be removed. So that yellow color can be removed by, if dry air or carbon dioxide is bubbled through the yellow acid, the later turns colorless because it drives out nitrogen dioxide from warm acid, which is further oxidized to nitric acid. Next, by addition of excess water, we can also remove by addition of excess water. Nitrogen dioxide gas dissolves in water and thus the yellow color of the acid is removed. The reaction is the reverse of the decomposition of nitric acid. Precautions. Precautions is 1. All glass apparatus is used because nitric acid vapors attack rubber and cork. So in the laboratory preparation, the glass apparatus that is used, we always use the glass apparatus because it can attack the rubber as well as the cork. Number 2, concentrate HCl is not used in place of sulfuric acid because HCl is volatile and hence nitric acid vapors will carry HCl vapors. So we can't use concentrated hydrochloric acid in place of concentrated sulfuric acid because it is volatile, and nitric acid vapors will always carry HCl vapors. Question 3. The temperature of the reaction should not exceed 200 degrees Celsius. So the temperature should maintain up to only 200 degrees Celsius because sodium sulfate formed at high temperature forms a hard crust which sticks to the wall of the retort and is difficult to remove, although the yield of nitric acid is higher. So what will happen, if the temperature is more than 200 degrees Celsius, it will form a sodium sulfate, which is a hard crust which can stick on the wall of the retort. So next is the manufacture of nitric acid by Oesterle's process. Step 1 is catalytic oxidation of ammonia. So first what will happen in the manufacture of nitric acid, we have got different steps involved in this. First is catalytic oxidation of ammonia. So in this, ammonia is treated with oxygen in presence of platinum at a temperature of 800 degrees Celsius to form nitric oxide, water and heat. In step 2, the nitric oxide that is formed is further oxidized by reacting with oxygen at a 50 degrees Celsius to form nitrogen dioxide. And in step 3, absorption of nitrogen dioxide in water. So nitrogen dioxide, when you treat with water in presence of oxygen, will form a nitric acid. So these are the different processes and the equations involved in the Oesterleit process for the manufacture of nitric acid in the use amount. So this is the flow chart that we discussed just now. We have got ammonia and oxygen. First it will form nitric oxide in a catalytic chamber, and after that there will be heat exchanger in which it will further oxidize nitric oxide to nitrogen dioxide, and after that when treated with the water it will form a nitric acid. Oxidizing properties of the chemical reactions. The copper reacts with nitric acid to form copper nitrate, water and nitrogen dioxide, and the carbon reacts with nitric acid to form carbon dioxide, water and nitrogen dioxide, and sulfur can react with nitric acid to form sulfuric acid, water and nitrogen dioxide. So this reaction shows the oxidizing properties of nitric acid. Test for nitric acid. There is a famous test known as brown ring test. In this test helps us to identify nitric acid or nitrate. Now what you need to do is add freshly prepared saturated solution of iron sulfate in a test tube. Now add concentrated sulfuric acid and acid carefully from the sides of the test tube. So first you need to take the iron sulfate solution. Okay, you can add a nitrate compound each way you are testing. Okay, that is nitric acid. Then after that you slowly add sulfuric acid from the side of the wall of the test tube, so that it should not fall dropwise in the test tube. 3. Cool the test tube in water. So after that you can cool it, the test tube. After cooling, a brown ring appears at the junction of the two liquids. So after cooling it, you will find that a brown ring has been formed between the junction of the two acids, one sulfuric acid and another nitric acid. If the brown ring formed, this means there is a nitric acid or nitrate compounds. Reaction is FeSO4 H2SO4 HNO3, giving you Fe2SO4 plus water plus nitric oxide. Now this nitric oxide will form a compound with ferrous sulfate FeSO4.NO, which is known as nitrosoferrous sulfate, a brown compound. So because of the formation of this, it will form a ring between the junction of the two liquids. Today's assignment 7, question number 1. The figure given below illustrates the apparatus used in the laboratory preparation of nitric acid. Okay, as we have seen for it. So your question is: A, name a liquid. Which one is A, liquid? B, solid, which is B, solid, and then C, which liquid is overproduced over here. Next, B, write an equation to show how nitric acid undergoes decomposition. And C, write the equation for the reaction in which copper is oxidized by concentrated nitric acid. Question number 2, fill in the blanks. Cold nitric acid reacts with copper to form gas. Which gas is produced? And B, give balance equation for the following. 1, laboratory preparation of nitric acid. Number 2, action of heat on a mixture of copper and nitric acid. And question number 3, mention the equations involved in the Oesterleit process, that is manufacture of nitric acid. And 4 is, what is brown ring test? Complete this assignment and send it in my mail.